Hello, fellas. This is another FRQ Type 4, which I made based on the Type 4 given in College Board practice question. By the way, the link of the same question is in the description in case you want to check. However, this one is a little more complicated. So let's solve. So this is the complete question. We're gonna move part by part. So let's try the first one. Okay, consider the function f and g defined as follows. So there's an f function, which is in terms of log, and g function, which is in terms of cosec and sine and cos. Rewrite f as a single logarithmic function which without negative powers. All right, let's see. Fx is 3 over natural log of x minus e square over natural log of x. Um, I think, okay, the problem which I'm seeing here is the log is actually at the, in the denominator. That's what is creating a problem for me. However, if I can change this 3 in terms of log, in fact, natural log, it could make sense. I could be able to solve this, right? So can 3 be written in terms of log, natural log? Actually, yes. Can I write this as natural log of e cubed? Because as per the properties of log, eventually 3 is going to drop down. Natural log of e cubed will be 3 natural log of e, and natural log of e is just 1. So 3 times 1 is 3. So indeed, I can write 3 as natural log of e cubed. So this becomes natural log of e cubed. ln x remains as it is. And likewise, how can I write e square? Can I write e square as natural log of e raised to e square? Because natural log of e raised to e square is the same thing, right? The e square just drops down and ln e is just 1. So it again becomes e square over natural log of x. All right, okay. Now, how can we condense this further? Remember change of base formula? Log a over log b can be written as log of or ln of e cube with the base of x. We can write that this, right? Because that will be the same thing. Log of a with over log of b is log of a with base b. That's what I wrote. Likewise, log of e raised to e square over, sorry, with base of x. This is how we can write this. And finally, log a minus log b is log a over b, right? So log with the same, in fact, why am I writing ln if the base is x? Well, that's weird. So I'm gonna erase this ln. I'm gonna write log with base x. Here I'm gonna write log with base x. And this is going to look like log a minus log b is log with base x. A over b. So this is the one, right? Log of a over b. Okay, with base x. All right, let's try to do part 2. Here we are given that write gx in terms of cos only. Okay, all right. So gx is given as cosec x multiplied with cos x over cosec x minus sin x. Okay. Let's try to convert everything in terms of sine and cos because as of now I do not really know where and how to proceed. So I'm just gonna convert everything in terms of sine and cos because it's always easier to think like that. So I'm just gonna write cosec as 1 over sine. Now I'm gonna take the common denominator on top and bottom. So it's gonna, in fact, there's no need for common denominator. The top is just cos x over sin x. But in the denominator, we do need to take sin x as a common denominator, and we are left with 1 minus sine square x. Okay. All right, what next? I'm gonna do keep change flip. So I'm gonna change, and I'm going to flip it. So sin x over 1 minus sine square x. Sin x and sin x is gone. So I'm left with cos x over, and guys, what is 1 minus sine square x? Cos square x, right? So this is cos square x, and there you go. what is cos x over cos square x? Isn't that just 1 over cos x? And that is our final answer, because that's what they wanted, right? They wanted this entire expression in terms of cos only, which we did. Right, I hope this makes sense. Let's move ahead. Now there are two functions p and q. Determine all the solutions of p equal to 0 within the interval of 0 to pi. All right, let's do it. Uh, px is equal to sine square x minus 2 sine x plus 1 over sine x. Okay. Uh, I mean, without even moving further, uh, I mean, I already see a simplification. I'm not sure if you are able to see this. Okay, let me hold on to that. We want px to be 0, right? Okay. So if we equate px to 0, then sine square x minus 2 sine x plus 1 over sine x should be equal to 0. And if a rational, p over q kind of thing has to be 0, obviously the numerator should be 0. So I'm just going to equate numerator to 0. So it's going to look like sine square x minus 2 sine x plus 1 is equal to 0. And obviously, we cannot afford denominator to be equal to 0. So we'll just put a note here that denominator should not be 0. Now, this is a quadratic in terms of sign. And if you remember, we used to solve this by making a temporary substitution. Let's call it whatever you like, maybe y. Let's say y is equal to sine x. So this is going to look like y square minus 2y plus 1 is equal to 0, which can be written as a perfect square. Y minus 1 whole square is equal to 0, which means that y is equal to 1. And there you go. What is y? Y was sine x. So sine x is equal to 1, which means that when is sine x 1 in 0 to pi? 0 to pi. I think the only value is pi over 2. So the answer is pi. That is the only value. Makes sense, right? The next one we have is part 2, where they want us to equate this to e raised to x. They want us to find the solution in the domain of q such that qx is equal to e raised to x. So let's do that. Qx is equal to e raised to x. What is qx? 4, 4 times e raised to 2x over e raised to x minus 2 times e raised to 3x over e raised to x. That should be equal to e raised to x. If you're going to simplify, then e raised to 2x over e raised to x will, just cancel one of the power of e. So I'm just left with 4 times e raised to x here. And likewise from here as well, one of the, power is gone. So 3x minus x is 2x as per the rules of exponents. And that is equal to e raised to x. Subtracting e raised to x both the sides, it will become 3 times e raised to x minus 2 times e raised to 2x is equal to 0. And I think we can take one of the e raised to x as a common factor. So we are left with 3 minus 2 times e raised to x is equal to 0, which means that either e raised to x is 0, which is just not possible, right? Because exponential function is never 0. It's always positive, e raised to x. So that's not possible. And the other possibility is the other guy, which is 3 minus 2 times e raised to x is 0, which means that 3 is equal to 2 times e raised to x. Let's flip the omelet. 2 times e raised to x is equal to 3. So e raised to x is equal to 3 over 2. So what is what is x, guys? Obviously taking natural log both the sides. So x is natural log of or ln of 3 over 2. That's the final answer. Hope this makes sense as well. It was a good question. Let's try the last one. Okay, now another gross function r is given, which has a radical and cos of 2x, etc., etc. They want us to solve for all the values of r. So mind it, they're asking for a general solution for which output is 1 over root 2, which means that the value of r is 1 over root 2. Let's do that. So r is 1 over root 2, which means that square root of 1 minus cos 2x over over 2 is equal to 1 over root 2, which means that square root of 1 minus cos 2x over root 2 is equal to 1 over root 2. So these two are gone from both the sides, crossed out. What are we left with? This means that we are left with square root of 1 minus cos 2x is equal to 1. How about we square both the sides? So 1 minus cos 2x is equal to 1 because 1 square is just 1. 1 is crossed out from both the sides. So minus 2 cos 2x is 0, which means that cos 2x is 0, which means that the general solution of cos is going to be, when is cos 0, there are two possible solutions. Either 2x is equal to pi over 2, and to find the general solution we just add 2 and pi, or 2k pi, whatever you write, whatever you like, and it's just an integer. Dividing both sides with 2, we will have the first general solution as pi over 4 plus n pi, or the other solution can be when 2x is equal to 3 pi over 2 plus 2n pi. So once again, dividing both sides with 2 will give us 3 pi over 4 plus n pi. That is another value for x. And this was the last part of this question. I hope this makes sense. Any questions, please post it down in the comment section, and I will see you soon. Bye bye.